Bienvenidos al canal DIY Onda Garage. Welcome to the Diagnostic Troubleshooting Guide for DTC P0141-01, which indicates a malfunction in the secondary heated oxygen sensor, HO2S, heater circuit for the Honda CR-V model from 2023 onwards. This DTC signifies that the Powertrain Control Module, PCM, has detected a problem with the heater current of the secondary HO2S, also referred to as sensor 2. The secondary HO2S is crucial for monitoring the oxygen levels in the exhaust after the catalytic converter, which allows the engine to optimize fuel efficiency and emissions control. The sensor is typically located in the exhaust system, downstream of the catalytic converter. Understanding this component's errors is essential for maintaining engine performance and meeting emission standards. Let's dive deeper into the details of this error code and its impact on vehicle functionality. The error code P0141-01 relates specifically to the secondary heated oxygen sensor, commonly known as sensor 2. Its primary function is to measure the amount of oxygen in the exhaust gases as they exit the catalytic converter, which provides essential feedback to the engine's PCM. This data helps manage the air-fuel mixture for optimal performance and compliance with emissions regulations. The sensors are usually mounted before and after the catalytic converter. In this case, the focus is on the second sensor, which plays a critical role in post-catalytic converter performance. The heater element within the sensor ensures that it operates effectively, especially during cold starts. If the heater circuit fails, it can lead to inaccurate readings, affecting not only performance, but also emissions control. Understanding these components is crucial for accurate diagnostics and repairs. There are several possible causes for the DTC P0141-01 error. One likely cause is a failure in the secondary heated oxygen sensor itself, which may have an internal malfunction that affects its heater circuitry. Another possibility includes wiring issues, such as breaks, shorts, or poor connections within the wire harness or connectors leading to the sensor. Essentially, if the circuit is not properly established, the PCM can't receive accurate data, leading to the DTC being set. Additionally, the PCM itself could be faulty, unable to interpret the signals from the secondary HO2S correctly. It's crucial to assess each component systematically to identify the root cause effectively. When the DTC P0141-01 is triggered, the vehicle may exhibit several symptoms. The most evident sign is the illumination of the check engine light on the instrument panel, signaling to the driver that a diagnostic issue has been detected. Additionally, the vehicle may experience poor fuel efficiency, as incorrect readings from the secondary HO2S can disrupt the optimal air-fuel mixture, causing the engine to run less efficiently. Furthermore, increased emissions can occur, which not only affects environmental compliance, but may also lead to potential failure during emissions testing. Recognizing these symptoms early is vital for maintaining vehicle performance and adhering to regulatory standards. The first troubleshooting step in diagnosing the DTC P0141-01 involves starting the vehicle's engine and allowing it to idle. This initial step is crucial as it establishes the operating conditions necessary for the subsequent diagnostic checks. Idling enables the secondary HO2S to reach its normal operating temperature, allowing the PCM to assess the sensor's functionality accurately. If the PCM identifies that the sensor is not operating within its specified range, it will log the DTC. This step serves as a foundation for all further diagnostics and inspections, ensuring that the vehicle is in the correct state for evaluating the sensor's performance. In this second step, the focus shifts to inspecting the secondary HO2S, specifically its internal circuitry. First, disconnect the secondary HO2S 4P connector to begin the inspection. With the sensor disconnected, use a multimeter to measure the resistance of the sensor's internal circuit. This resistance should fall within the normal range of approximately 4.2 to 6.6 ohms at room temperature. If the reading falls outside this range, it indicates a fault within the secondary HO2S itself, signifying that it may need replacement. This step is critical, since ensuring that the sensor's circuitry is intact will determine if it operates correctly under normal conditions. The third troubleshooting step involves inspecting the IG1 SO2 circuit to ensure it is functioning properly. Before proceeding, ensure the secondary HO2S 4P connector and the PCM connector B101P are disconnected for accuracy and safety. Using a multimeter, check the voltage supply in IG mode. You should be measuring around 12 volts, indicating that the power supply to the sensor is sufficient. Next, inspect the SO2 wire for possible open circuits or shorts to ground. If the inspection reveals an open circuit, it could imply a broken wire or poor connection, which needs immediate attention. This step is vital as it rules out wiring issues that could affect sensor performance, allowing you to focus on the PCM if necessary. The fourth troubleshooting step is to closely examine the SO2 wire connection for any potential issues. After completing previous checks, focus on ensuring that there are no shorts to ground in the wiring. Use a multimeter to check that the resistance from the SO2 wire to ground exceeds 1 megaohm. If the resistance is lower, this indicates a shorted condition, which could severely impact the performance and reliability of the secondary HO2S. Addressing any wiring issues detected during this inspection is vital, as they can lead to erroneous signals sent to the PCM, ultimately resulting in further DTCs if not resolved. The final troubleshooting step involves checking the PCM if all previous components and circuits have been verified as functioning correctly. If the diagnostics lead to this point and the secondary HO2S, as well as the wiring, have proven to be normal, it indicates that the PCM may be the source of the problem. Inspect the PCM for any faults, including potential hardware issues that would prevent it from processing signals from the secondary HO2S. If abnormalities are found, it would necessitate replacing or reprogramming the PCM to restore normal operation. This final inspection validates whether the issue lies within the control module or elsewhere within the system. After completing the necessary repairs in response to DTC P0141-01, it is important to conduct a final verification process. Start by clearing the DTC using the Honda Diagnostic System, HDS, to reset the PCM. Once the codes are cleared, it is advisable to take the vehicle for a test drive to verify that the repairs were effective and that no new codes appear during operation. While driving, observe for any abnormal performance or check engine light illumination, as this can indicate lingering issues. If the DTC does not return and the vehicle operates normally, it confirms that the repairs were successful and ensures optimal performance and compliance with emission standards. To prevent future occurrences of DTC P0141-01, implementing a regular preventive maintenance routine is advisable. Begin by conducting periodic inspections of the secondary heated oxygen sensor to ensure it is operating correctly. Monitoring engine performance can also provide insight into how well the sensor and system are functioning, allowing for proactive interventions before major issues arise. Regular oil changes, air filter replacements, and exhaust system inspections can further contribute to maintaining sensor longevity. Keeping an eye on fuel efficiency and engine responsiveness can help detect issues early, ultimately prolonging the life of the vehicle and ensuring compliance with emission standards. In conclusion, addressing DTC P0141-01 requires a thorough understanding of the secondary heated oxygen sensor and its role in maintaining vehicle performance. By systematically troubleshooting the error code, technicians can isolate the issue effectively, whether originating from the sensor, wiring, or the PCM. Regular maintenance and inspections of the sensor and associated systems play a critical role in preventing future problems, ensuring both optimal engine efficiency and compliance with emissions regulations. The comprehensive approach outlined in this guide provides a pathway for effective diagnostics and repair, ultimately supporting the longevity and reliability of the Honda CR-V from 2023 onwards. Dale like y suscríbete al canal. Hasta la próxima.